All right. Hello, hello, hello. How's everybody doing? Cool. Let's get this started. Okay. Stream elements alert went out. Tweet went out. Got this cord figured out. Got my red colored water. Okay. Where did we leave off yesterday? So I've been playing around with this a little bit, and we did. So I did something which I normally do, which is this like little tiny bit of logic, which sets a Boolean value outside of the handler during the initialization time. So we were already recording the date when we initialized the function. That was fine. And what I do is I set this is cold start true Boolean, and then in the handler I have this like cold start result set to false. If cold start is still set to true, which it will be on the very first pass through this code, we set cold start as false, which is the outside variable, right? And then we set cold start result to true, and then we return cold start result. So this was already deployed, and now I want to refresh and load. And this is still a nextjs function. So there's two things I want to try next. The first is I want to just create a new project without nextjs, and that was something Tom suggested that I do. No nextjs at all, just a pure Vercel function, and then test that at an end time. But there's something else that's very curious that's happening, which is I'm getting a really fast response back from the very first call, but I'm not seeing the value of this Boolean being set to what I would expect. So what I think is happening is they're like pre-warming the node process, which is a good idea, arguably. I just want to be able to see that, see if that's actually happening, see if that's actually the case. So this should be out, and it should have been 15 minutes now. So let's see. Yeah, this is an hour ago, right? An hour ago? Yeah, okay. Cool. So refresh this. This should still be true. This is an old timestamp. Okay, so that was a cold start. Is cold start result true? That looks good. Now if we hit this again, it should say false if the code is working. Okay, and now it should say false for the rest of this. Yo, Koki, sorry, keep getting this wrong. Welcome to chat. Thanks for hanging out. I know it's a evening stream or a little later than normal, but I had to go to the F1 arcade and try out the racing today, so I did that. Thanks for joining. All right, so this is working. Let's get a deploy out because this isn't what I'd expect. Oh, I want to know, can I find out what time the node process started? I think I could, so this is a Lambda. So what I did was I just dropped into a Docker container image running the latest version of Node 20 from Lambda. And if you haven't seen this before, there's the root where you get dropped in is var task. This is like your handler code goes here, right? And it doesn't even have clear. Of course it doesn't. Okay, so what we want to see though is what time the node process started. So if we cd var runtime, this is where node runs. So I think it runs node index, and some other things, right? Some other arguments. Or is it bootstrap? Which one of these is executable? Oh, yeah. Okay, so a little goofy, but that's what it gets called. We could copy this out and look at it. But this is literally it's just like a little shell script. And it's got some node modules. It sets the node path environment variable, and then it launches the Node.js process. So export node execution and then node args. It sets some other values for max header size and then calls var runtime. But I think I just don't have any other crap here. So it's crashing. So I want to see if I can get when that node process started. Is there? Here we go. Okay. Perplexity.ai. How can I find that? I wonder if we can stat. I think it would be stat on. Oh, there's process.uptime. Never mind. Amazing. Okay. Boom, boom, boom. Okay, let's check this out. So let's see. Okay. So that's just the number of seconds it's been up, right? Oh, yeah. So that's fine. We can just get the number of seconds it's been up, and I want to see if they warm it up, basically. So let's. This is perfect. Nope, that's our Node.js function in Lambda. Okay. So in. Okay, so in static init, if they're warming up our handler, this initialization code, or I'm sorry, if they're warming up the process, this initialization code will not have run, but the node process will be running. So process.uptime will be running. It would be it's similar to if you did this. You run node at some point in the future. You run, const my handler equals require, and then some code. So this is normally what Lambda does at the beginning of a cold start right away, right? They start node and they include your handler. I'm guessing because this like cold start result thing isn't, well, maybe let's demo it first. So let's just do a change, Okay. Oh, let's just do, date.now, just so we know this is going to change, right? Okay. Demo cold start changing. Okay, so what happens is that it will still say it's a cold start, and by it I mean this bit of code, this whole static initialization time, which again Lambda would normally run on a first cold start. I think Vercel still does it, but what they do is they warm the Node.js process in their deployment loop. So they have a deployment, it deploys your Lambda function, then they warm it up with some sort of like direct invoke, but that invoke doesn't actually execute any of your code. And that is smart. I think that makes sense because most users, or a lot of users, would have like, what's a common database service? I wouldn't know what, Drizzly, one of those is right. You've got like, MySQL connection equals, require MySQL, and then MySQL connection, right? So you do that, right? Not mystery question, MySQL connection. So you do something like this in your initialization, and they don't want to pre-warm that for you if you're not going to call it, because you may starve yourself of threads. So that makes perfect sense not to do. But they are definitely warming it up, because we can see that waiting 15 minutes, we get a much slower cold start than we do. And what I don't want to do, effectively, what I want to make sure is that I'm not including values in this measurement which aren't actually cold starts. So taking it from the top, we want to measure the end-to-end round trip duration for a cold start in Vercel, because they have this new Rust-based wrapper. It's supposed to be a lot faster. Want to check that out. And to do that, we have to make sure we're actually looking at cold starts, and the very first deployment isn't exactly a cold start in the way it would be on Lambda. So I can't rely on it in the same way, which is good, because I just think that Lambda should do what Vercel does here all the time. Okay, this just got done 2 minutes ago. All right, hit this API. Now, what you should still see is cold start results going to be true, but this is going to be a very fast request. And we can even time it, right? Time curl. So that's 337 milliseconds, pretty quick. However, you can see cold start result is true. What I think is happening is that the process has some uptime, and let's demonstrate that. So, okay, we don't need this. We need process uptime. Thank you, Copilot. So what this will tell us is how long this process has been live. And if we get a cold start, we would expect the process would be very, very shortly lived, right? Like pretty new. And I'm wondering if it's not. And if that's not the case, I wonder if there's something else going on. But let's find out. We'll learn together. Hey. Oh, I need to make this repo open source. I promised I would. But I have to create a new project anyway. So let's, how do I do that in Vercel? What's the fastest way? Do I create a new repo to start a new project in Vercel? I think so. Hey, Nacho. Welcome back to the stream. Good to see ya. Thanks for checking in. Hope you're doing well. Okay, I think we need a new project. Vercel, what do we want to call this? Because we've got Vercel runtime, which I don't think is quite right, because that was going to be the runtime wrapper. We need to do this. Okay, let's call that cd Vercel plain function. Okay, what needs to go in here? It's literally just an API. Okay, so I was reading this blog, and you just need some directory like index.js or .ts. So I think we need a package.json file, and then we need and this is a TypeScript file. So we could probably just do a TypeScript project. How do we do npm init TypeScript project? There's like a command. Oh, I don't know if I want to watch DigitalOcean's example. Oh, it is still npm init. Okay, so just save dev. Okay, that's fine. npm init-y. npm id. Is it lowercase d, uppercase d? I always get that wrong. It's got to be lowercase d, right? How we do? Nope. Wrong. No, I don't want to do that. It's capital D. How we do now? There we go. We got a dev dependency. Okay, now this Vercel type is also a dev dependency, I think. Yeah, so let's just do this. That should be probably types, I'm guessing. Oh, that is a lot of dependencies. Okay, yeah. Make dir API, nvim API, and then is it just index.ts we can just do? Yeah. Yeah, okay. Okay, let's just get a hello world going here. And this should just be a plain function, no nextjs. That was the biggest criticism I think I heard, which is totally true. I didn't know they even did this. Is it mad at me? Okay. Okay, now we need a repo. And now we need to create one, which means we have to go into fuzzy mode. Secrets are no fun. All right, chat. Thanks for folks who are hanging out while I MFA. Some regulars here. Always good to see you both. Kochi, Naxo, Nacho. Where is my... There we go. GitHub. I think it's called Vercel plain function. Okay, I'm not typing anything that risky here. Okay. Public. We're going to make this one public. Oh, yeah. Here. I think it's going to make me MFA. Oh, no, it didn't. Okay. Sweet. Okay. Chat. Keep me honest. This is public. You can see this, right? Hopefully. Let me know if you can't, and I will figure it out. But, okay. All right. Is it dash upstream like this, I think? Nope. Get remote add. Okay, just get remote add. Is it main or origin? You know, I was going to get there. We probably don't need the node modules. Oopsies. Yeah. Okay, that should be good. Oh, right. Okay. Oh, well this, yeah, so we need a script for run build, nvim package.json. I'm wondering if build, and this should just be like TSC, right? Yeah. Is it TSC dot? What did it complain about? Oh, I know it's TypeScript. Oh, I need a tsconfig.json. Oh, yeah. That was what I was missing. Okay. Okay. Vercel. Runtime. Okay. Okay, we don't need a path. It's just /star. I don't think we're using the next plugin. I don't think we care about JSX. Okay, we're just guessing here, chat, so that's fine. We don't care about these types either. Okay. Does this go? Okay, that looked like it worked. Okay, the real question is, will Vercel figure this out? Okay, let's see if we can just hook this straight up to Vercel real quick. What did I miss? Okay, if not, we can always use plain JavaScript. I don't want to fight it too much, but I think most Vercel users are TypeScript users, and I don't want to fight the platform. Okay, we still have our pro trial. Thanks again for Lee Rob for helping me out with that. Team speed. Add new project. Oh, here we go. This is what I need to freeze you all. All right. Nobody look at all these things I'm a member of. Just kidding. I already linked it. Okay. Oh, yo. Thanks for the follow. I don't know how to pronounce that, but welcome to the chat. Thanks for hanging out. Okay. Save. Import. Does this know? Okay. Is there none? I'm not using a framework. All right. Vercel, don't get mad that I'm not using a framework. Oh, that should just use, okay, it should just use build. Let's find out. Goofed around too much. Oh, okay, so it didn't like that. Did I miss something here? Oh, it must be some other config that puts it in public. Okay, let's just find out. We just need TypeScript destination directory. Okay, so just outdoor public. Okay, let's try that. Oh, wow, I didn't capitalize that right, and it's complaining. Unfortunate. Okay. Did it really put it in slash? Wait, what? There's nothing there. What am I doing wrong here? This looks fine. What did I do wrong? My TypeScript config. That's not working. I just do? I gotta have something wrong with my actual code then, right? TSC outdir dot. Is there not a verbose mode? I'm using -- build. What? Compile option outdir may not be used with it. Well, that's why I should probably read the message. What did I do wrong, chat? That's fine. Tsconfig. What did I do wrong? Tsconfig. Is it this thing? Is it my paths? Oh, I don't know if I even want any of this actually. Let's just do, okay. All right. That's what happens when a backend developer decides to start messing around with Vercel. That's fine. TypeScript config guide. Bam. Oh. Okay. And then, okay, so there's also this path option, and that must not have been something I care about. Okay. That in compiler options don't include. Okay, so that looks good. What's out file versus outdir? That makes sense. Why doesn't this? Oh yeah, hey George. Yeah, I got permission. Why is this? So I was trying to copy the project that I got from nextjs, but I don't want to use Next because the framework can slow down the initialization, and some of the developers told me that in chat, so I don't want to. I'm trying to set up a plain Vercel function. Oh, we can just, yeah, npx tsc API. Does that emit anything? Oh, well, okay. Can't find module. Well, that would have been nice to see. Doesn't stream web. What is this? Oh, they're all types. Okay. So I've got some dependency that I didn't realize I needed. Something. Oh, George, so that's a good question. Am I going to port my entire project for the Lambda benchmark? It's going to have to change a lot because it was, oh my God, I've been on secret mode. Chat, you got to tell me this. I'll have to change it a lot. It needs to evolve significantly because the original project is using like a AWS Lambda direct invoke, and I obviously don't have that option on Vercel. Which is not a problem. Happy to just use curl. What do we use for build here? Oh, it does next build. Okay, so that's what I've got. That's the problem I have, is that this build is different. Okay. Okay. I should write more JavaScript. Build TSC. Oh. Do I care about the main? Yeah, let's find this out. Let's just, how do I do a tiny little TypeScript project? I've done this before. Why don't I just look at this projects that I have? I think I've got, this is a TypeScript project. Oh, and then it packages it to dist. That looks pretty similar though, doesn't it? It's just include src. Oh, there's some .ts here, but that shouldn't change anything. It's still a .ts file. Oh, we could add skip lib check. That might help it build, because maybe it's complaining about a type missing from one of my dependencies. Oh, we've already got that set true. What the fuck? It's mad at this dependency. Like if I do... It's not a JS file, it's a TS file. Oh, did it got compiled into API. That's what's going on. Okay, rm API index.js. So did it not get my directory? No, somehow I built it. It built fine. Should we just install this package and see what happened? What the hell? I don't even have this package. That's what I don't understand, is that there's no fetch in here. I'm not using fetch at all. But something like... These types must be goofy. Okay, let's just do... Can we get rid of the Vercel node stuff? And just have TypeScript? Oh, yeah. Okay. Thank you for nothing, TypeScript. We should have just done this with JavaScript and been done. That is fine. Okay, so it's generating it. But it's not... Oh my god, it's a .ts config, isn't it? Did I get that wrong? No, it'll use that. Why is it not honoring the outdir? The file name is right, but I think the other thing that could be wrong is this. It should be public/index.js. That's probably it. Nope. So it didn't build anything. What other flags can happen here? all init. Oh, I wonder if we arm RF. Incorrect target. Thank you for the follow. Welcome to the stream. Okay, so we can do npx tsc init, and maybe we just have a bum package. Whoa. Wow, that's a lot of stuff. All I wanted to do is be in the public directory because I think that's what Vercel wants. Oh, there. Hey, there we go. Okay, it works fine. I had something wrong with my config. It didn't tell me what it was. All that looks great. Okay, can we go back to the types so I don't feel like a total clown? More than I already do, which I always do on stream, so I appreciate y'all being here. Okay, Vercel node. There we go. Let's get our types back. All right, thank you for this blog author. So it's got to be API. Does the output have to be API too? Probably. That works. Okay. So I think I just need, it should be like public/API. So we should just make that change. I don't know how to run a whole project like this, but that's fine. Maybe we're just targeting CJS. Okay, perfect. Okay, let's see if they'll build this. Oopsies. Okay, let's see if Vercel will build this. It's a little bit of a box to me that I don't fully understand, but hopefully we'll get this going now. Change. Deploy. What's the last commit? Will it have picked up my commit? I think it will. We can check. Git log grep map. Okay, yeah, that's TSC works. That's fine. Hey, okay. Build completed. Let's see if it's got a URL. I'm guessing 404 not found. Congratulations. Slash, what is it? Slash API? What do we call it? Yeah. Hey, okay. We did it. We did it, chat. We made a lot of progress here. Perfect. Okay, so now we need to do two things. We got to copy that work we did earlier. Vercel runtime slash whatever. What is it? It's in src app API route. I don't think we need force dynamic. We just need, we're going to need the static init time. We're going to need, I don't think we have to read the file system anymore. But we want our little cold start voodoo. Okay, so now we need to make a couple of edits to the response. Let's grab it from down here. Oopsies. No value exists for this data. We don't need data, that's fine. Oopsies. That looks good. What is it complaining about? Value never used. Okay, chat, we are cooking with gas now, aren't we? Okay, Vercel plain function. Oh, we wanted the process. We wanted to know when the process started, right? Process.uptime. So we get that back here. Okay. Cool. All right, that is rolling. We're making progress here, team. That is gonna build. We already, so for folks just joining, if you're new, we've already built this very similar. Oh, we don't care about the env. We should do the uptime. Yo, Dota 2 attitude. Thanks for joining. Welcome to the stream. How are we making it faster? Good question, Dota 2. So I'm not, I didn't make anything faster. They have improved their Lambda extension, which they use to, I assume, offer response streaming or some other features of their runtime, some of their managed runtime. It's written in Rust now. Previously, it was written in JavaScript. They said that would make it substantially faster. I mean, I think it does. I read a lot of Rust at my day job for the same reason. So I wanted to see how much faster it was, and I wanted to compare it with like a regular Lambda function running in AWS Lambda at my own account. So we've got my own account, which is where I mostly work, and then I'm struggling to learn Vercel, which I think is very user-friendly. I'm just not used to it. So I'm not trying to make it faster. I'm just trying to measure it. And for a ton of reasons, rewrite in Rust. Gotcha. Yep, see ya. Thanks for joining. Rewrite in Rust. For a ton of reasons, we want to record the end-to-end latency. So I've got a system that sort of does that, and I'll talk about that as we get there to part of the project. But we need uptime. What do we call this? We need to make it the exact same, because what we're going to do, we're going to feed this into our system. So we need to consume this output. This is a JSON output. We need to write a Lambda handler that will call each of these, get the response, drop it if it's not a cold start, and then record it as a series point, as a metric if it is. And then we're going to track it. We're going to let it run for, I don't know, a couple weeks. I think I have left on my free tier before I have to give them a credit card. Which I already emailed them. I was more than happy to put a credit card down to cover anything related to this. I have no problem with that. I read the terms and conditions, which is where I saw the clause, but I also read their billing model before I started playing around with all this stuff. Dota 2 attitude. Why not anything else? So a few reasons why not. Lambda isn't. It doesn't run it doesn't run in and of itself, right? It runs in this whole distributed system. So if we like pull up our Excalibur, most of the time when you're talking to a Lambda function, there's something else in front of it. And typically what will happen is that there will be a API gateway in front of it, and or a similar function API gateway. So this gives you, HTTPS : my function .us east 1 .aws what is it, Amazon AWS.com, right? I think it's like .lambda, it's got some, I'll show you the URL in a second. And it sits in front of your Lambda function. So we are doing, Vercel does that for us. Just the Lambda got rewritten. So no, there is a shell around this Lambda function. In Vercel, there is a shell around this Lambda function. And what it is called a Lambda extension. And the beautiful color is because it's written in Rust. So they use this because they have to, they're building a product on top of Lambda. So they are doing metering and doing billing and adding features, and they do it with this extension. And this extension kind of wraps your function. So the extension receives the request, sends it to your function, receives the result, sends it back to the public internet via API gateway. Or I shouldn't say that, via whatever, we don't actually know what's sitting here. Could be API gateway, could be Kubernetes, could be a bunch of stuff. But AWS doesn't, Vercel doesn't let me just use, Lambda. I have to go through the URL. So, and I can't run anything on Vercel. It has to be Node. So, but I'll test in Node. I'm not going to write a Rust function in AWS and compare it against Node. I'm going to use Node 20. We dumped the environment variables for the project, and we saw it like it's an AWS Lambda function. Here, I'll show you. Wonder if you can run the test in their system. I don't know if that would be something we'd want to do even, because the goal isn't to just like the goal isn't to gotcha or do anything like that. I just want to test it. Yeah, exactly. George is right. Like I want to test what you and I would get. Now I'm intentionally not using next, and that's like a good reason. Like not everybody runs next in Lambda or on Vercel, so like we can just do a plain function. I'm not sure what you mean by adds noise. Can you clarify that? Like their Lambda wrapper got rewritten in Rust. Lambda itself is still the same thing. It's still Firecracker. It's also Rust. You can read it. This code is very easy to read. Yeah, the noise is part of the package if you use Vercel. Exactly. So like you have to use it. So I want to measure it. But I do think it'll probably be minimal. So let's find out. Okay, this should all be up. Open source BT dubs. Wow, we got to give that a star. Can't just sit on it by itself. Dota 2, I can. There are a couple things I can do to account for that. I know when this request hits Lambda, or hits the Lambda function itself, right? We have a timestamp for that. So if we can even account for overhead in their system, it will just get rolled up with overhead in the API gateway. But I will test with the Lambda function URL, which is the closest thing I have anyway. We should add a comment. Don't do this if you have secrets. I don't think I have secrets. Yeah, exactly. So I work on Datadog's tracing layers, tracing observability, and we can trace API gateway by inspecting the packet and by using some inference. So we know how long that took. I don't know, like I said, I'm not sure what will come through in Vercel, but it's certainly possible. Oh, I wanted to see if process. Okay, so we haven't hit this function. This function should be cold. All right, chat? This function should be cold. But I want to see what process.uptime is. Remember, this is measured in seconds. If you haven't seen this before, uptime. We did it right away. So that's 1.5 seconds. We wait a second, 2, 3, 4, 5, 5.35. Okay. So let's see when this runtime started. Okay. So they just started that process. That's pretty cool. So they've got something going on. So this should still get longer. Yeah. So 6 seconds. Neat. So they are doing something to make that node process launch faster, because that is a pretty quick launch. My hunch was that they were pre-warming it. But there's other ways we can check. We can check the age of the file system, right? And figure out when it started up. Okay. But it doesn't even matter because we want to see... in their blog post, they said they waited 15 minutes to get a cold start. Are you sure it's Node and not some modified version of Node? That's a good question. We can try and find out. Let's. I mean, I can tell you it's Lambda because I recognize the environment variables and I recognize the directory structure. Like there is, we listed it yesterday with Lee Rob here. There's like a /op directory where the extensions live. There's a var task directory where all of my code that I just wrote is, and there's a var runtime directory with all the regular Node 20 runtime stuff, which I don't think they would remove. Like that's just where it lives. But whether or not they call it is different. They could definitely do something different with how they call it. Okay, let's okay, so you can see we'll wait, why is it? Yeah. Okay. So we'll remove this in a second, but I just want to demonstrate this. I'll show you the environment variables that show that it's like a Lambda function. You'll be able to see it. Rust is not a server bullet. Rust is pretty awesome though. So I think when they say function bridge, they mean Lambda extension. Tom was the engineer or an engineer who came into chat yesterday and was replying to me on Twitter, and he mentioned they are using Lambda layers. So I presume that's why, because there's like runtime modifications, which means it can't just be a library. Okay, ready just now. Okay, so you can ignore these because these won't last long. The access key and secret are going to expire really quickly. But these are all AWS Lambda environment variables. There's a function version, initialization type, on demand, My hypothesis was that they were using provision concurrency for some functions, but they're not. You can see that it's running in US East 1. Like these are just the regular environment variables all of our functions have access to. So it is just a node function, and it's a node 20 function. And this is the things I was describing earlier. If you actually like ls these directories, they're the regular Lambda runtime. And again, I think they're probably they can make significant changes to, significant changes to how they launch Node, especially Node options would be what I'd look for. Oh, they just set the max header size, which I think is the same as they do in the Bootstrap script. So that's just being set by Bootstrap. But you could pass more things here. So they have an extension that wraps this, and you can see that via, oh yeah, exec wrapper right here. So this is their Rust wrapper. But in their guide, they said you had to wait 15 minutes. I was really hoping to find a way to shortcut that to make this testing faster. It might not be. So I think what we'll do, we need to remove this because we don't need all this data. But I just want to show it to chat. You can run Vercel node. I mean, yeah, of course you can run Node and Vercel locally. Just JavaScript. I just prefer to test in Lambda. Boom, 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 boom. Oh, Lambda log FD. Of course, so they're shipping logs with the telemetry API. That makes sense. Process uptime 31. Yeah, so if we refresh it, it'll be like up for 142, right? It wouldn't be on their machines, etc. in that case. I'm not sure, Dode, I'm not sure what you're getting at. This entire thing is running in a Lambda function, I think pretty conclusively. And they've said that, which is fine. I mean, like that's great. Oh, thinking out loud. Okay, keep at it. Okay. Well, we don't need to display anything, and we can remove this. Okay. So if you get scared because you saw that those AWS keys in there, like those keys are in what's called the Lambda execution role. So every Lambda function has a role, and then it gets temporary credentials when it runs, and it does that to talk to other AWS services, or basically for AWS to kind of allow it to live. And that's expected. That's normal. Those expire, and they can only work with a principle of Lambda, which is to say, Lambda will see which IP address and which service you're coming from in its own control plane, or AWS will, and if it doesn't match. If it's not coming from Lambda, these will get rejected. So you can't really use them after this. And if you're wondering, node path, this is how your node modules are resolved. So opt node.js node, that this is how Lambda layers work. It looks in this directory. Lots to learn with Lambda. Okay. So we're going to hit it once. Oh yeah, there's tons of performance stuff in Node. Oh, okay. So that was already running. That was 26 seconds that's been up. So we just did our very first request. Okay, so they are warming this process. Chat, everyone see this? So I did this deployment. They start the process. And then my function still says it's a cold start. So what they did is the equivalent of this. They did the equivalent of node right away. Right after I built, this means that they're invoking that Lambda function. And when they do that, they just start the node process, but they don't actually load your code. And then at some point they do const, handler equals require public API index.js, right? Now, if you look at like process.uptime, it's still quite long, 24 seconds, but handler dot, handle, what is it? What is the default? Oh, it doesn't have a status. Oh, okay, response doesn't exist. Jay the developer, welcome to chat. First. Okay, this won't run because this is expecting Vercel's magic global that does this response, but we didn't pass it one. Sorry, it's not expecting Vercel's magic global. It's just an argument that gets passed in here, and we're just not using it. But you see what I mean? Like the process.uptime is still set when the node process starts. Oh yeah, Jay, you're New Zealand, right? Somewhere far from me, far from Boston. I don't normally get to stream at night. I mean, I try not to, but today All of my chores. Somewhere in New Zealand. Awesome. Hope you're enjoying the fall. Node 22 exists. I feel so left behind. Yeah. You can find my name in a lot of the GitHub issues talking about how far behind AWS is on Lambda versions. I've harped on them for so long about this. Okay, great. This is great. Okay. This is good. We want to let this cook. I want to let it cook. Yeah. Well, I'm on 21. I mean, no flex. It's a non-stable or non-LTS version. Let's get this out to regular Lambda. What do we do? So we have the same cold start result. It should be almost the exact same handler. This is not TypeScript. Don't get too mad. We're not reading the directory. So we read the directory yesterday because I wanted to do some work. Bold move on the odd number. Yeah, so George, exactly. Like swapping to Go is great because you bring your own runtime. And I've been writing a lot, like I said, I've been writing a lot of Rust lately. And that has been a big part of, like not a big part, but that's been like a excellent part. Yo, Melky, what's up? Shout out Melky. Thanks for joining the chat, man. We'll give you the quick shout out. I'm sure you all know Melky. I think if anything, you're here because Melky rated me once very kindly. Yo, Robin, thanks for the follow. So we've got this running. It's the exact same code running in a very plain Vercel function on Vercel's platform. We have permission to test. Thanks, everyone. Oh, wow. Typing turtle. Yo, thanks for the follow. Okay, let's... is this set, actually? Should be set still. Okay, click. Okay, so remember these URLs? You remember these URLs? That's what I was talking about. We'll just get one of these. Oh, yeah. A bunch of people I work with work on Node 22 performance. Google Node diagnostic channels, I'll put that in chat, and then you can find a bunch of Datadog engineers work. Tons and tons of really sharp people work on this stuff. Oh man, Node performance. You should talk to Yagiz. You should talk to Mateo. There's some really good people on in the Node ecosystem. They've been more than kind to me. Shout out Mateo if you're around. Probably not. It's pretty late. But yeah, he streams his work while he works on Node. I look at C# garbage collection random usage. Yeah. And if you write Go, you should check out my coworker Felix's blog posts. You probably already follow him. He's got like 30,000 followers on Twitter. Let's just deploy this. Yeah, Felix modified Go, had a couple PRs into Go's runtime in order to unwind stack frames, stack pointers for the profiler that we're writing at Datadog, and anyone can use because it's in Go itself. It's sick. Yeah. Oh shoot, what do the kids say these days? Cracked? I think they would say cracked. How do I spell your last name? Yeah, here. Where is his PR? He just dropped it in Twitter too, is wild. He's like, oh, by the way, I rewrote this and now stack pointers work. Yeah. Here, you should follow this thread. And follow Felix. Felix is awesome. This is the person, every time I have a really, really hard question at work, he helps me out. He helped me rewrite parts of Go's linker. So why are you in Vercel switching to Rust? Thank you, Melky, for that. Two huge reasons to switch to Rust while we let this deployment run. Let's go to Excalibur. And I'm not switching everything. I'm switching between the Moonlander and the Advantage 360, and I'm struggling. Okay, so why Rust? Okay, two reasons. One, memory safety, and we'll talk about this. And two, we should just talk about general oh, worst Tyler, thanks for the follow. We'll talk about performance, but I want to put an asterisk on it. Okay, memory safety. What does this mean? Nil doesn't exist. If you're a Go developer and you're used to writing, if not nil, That doesn't happen anymore. And it doesn't happen because Rust makes you handle every single edge case. And we can just like take a look at my last pull request. Ooh, we're writing some C. You should learn C. C is great. I don't think there's a problem with that. So I'll just show you a really quick example. It explicitly states a value is nil. No, Melky, nil doesn't exist. It's more than that, right? Nil is, it's not a thing. You can't return nil. You can return none. So there's this idea of a result, which can either return something, and this is of course a generic, or an error. That is one option. And then there's the idea of a oh God, I'm blanking on this. It's not a result, it's the other one. An option, which has some or none. So if it has none, you have to handle it. And I think, do I have some in here? Okay, yeah, so this is a great example. So what I'm doing is I'm parsing the string. The string can be, it could be either a quote that just says end, and then I match and I say, okay, that's a flush strategy end. So this configuration option is end, it gets mapped to end. But if it's something else, we now jump into this case. And this is what we're expecting. C as a null pointer, I don't think it's a concept of null yet. We can still have null pointers, but only one. You can't share them without explicitly cloning them or sharing them through an atomic reference counter. Yeah, like the null terminate, like /n still exists, but there's no like nil variable, no value, no nil value. So let's just go to this example. We're parsing the string periodically, 60,000. This is a strategy and a timestamp. We split the string. That's what we're splitting on. So I'm saying, okay, if it has something, if we split it has something, do this. But you always have to handle the none case. So now I have this like other case. It's actually falls into this case where like there's nothing here. So what happens? And you have to do that over and over again. And the same thing. Now we split the string and we say, okay, call next. We know it's going to be periodic. That's great. Now match. Is there something here? Did they put a number here? Does this number parse? If the number parses, that's great. Use it. Now it's an integer. We know this will always be an integer. But if not, we fall out of that case. And in this case, don't get confused so much by the okay. That's part of the result. There's okay and error for the result, right? Okay, it returns some type. Error returns some error. In this case, we're always falling through. So instead of nil, you like explicitly handle all these errors. That gives you some example on memory safety. Nil doesn't exist, so you basically can't have like no nil pointer error. This means no runtime crashes. Yeah, exactly. Typing turtle. Welcome to chat. This is part of it too, right? You get lifetimes, and lifetimes are these weird little bastards, and they look. Oh no, did I? Yeah. I just closed it. You also have to handle the nil case. Yeah, you're right, George. They look like this. You'd have like some, some type. I guess this will be a little weird. A, like that. And then you have like function and then the name of the variable. And this gives you a lifetime for A, and you have to either explicitly pass everything through that lifetime, or you have to like, it dies inside a function. So implicitly, there's also, as a result, well, let's jump into the next part, performance, no garbage collection. So one thing they'll talk about, and Felix will talk about a lot, is a programming language like Go or C++, actually not C++, sorry, garbage collection language like Go, Java, Node, .NET will all have various types of garbage collectors. The two main types are mark and sweep garbage collectors, or reference counting garbage collectors. At some point, you will be out of memory for your process. Your process will allocate a certain amount. You can check this out. If you're running a Go program, you can do, Go show GC stat. Is it GC stat 1? Go debug GC stat 1. There's some, yeah, GC trace equal 1. And it will actually tell you, and it's pretty cool. Even on a Lambda function, you'll see like it'll start and it'll say, okay, we're going to give you 1 megabyte of RAM. And then you like allocate some of it and say, okay, we have to pause the world and we need more space. So then Go goes to the runtime, in this case Linux, or the kernel, and says, malloc, please, like give me more memory. That's a kernel mode switch, gets more memory, expands that heap, and then you can allocate more space. At some point, your program has to pause to defrag that, right? So you're allocating tons of little pointers, tons of little slices of memory, and then at some point you have to put that back together. With Rust, you do that yourself. This is what gets weird though, because now you have to think about algorithms to allocate your memory. And in a lot of cases, you can use what's called like a bump allocator, where you sort of just like take an array, you know, and you can like, you know, visualize it like an array. You get like, you know, 124 kilobytes or bytes of memory. Then you get another 124 you need it, and you just sort of keep it around forever. And if you don't have unbounded input, then eventually your program grows to the size it needs. It's more common. What you do is like a tree-based allocator, where you'll have like either a binary tree or some, you know, B tree. Just finished the Rustlings quiz too. Where's Tyler? Welcome to chat. Yeah, it's a lot, but don't stress it. If you want to learn it. Don't stress it. I'm using it very specifically for these reasons. And I would say if I was gonna quit today, I would probably write if I was gonna write a backend API, I'd probably do that in Go. Anything I'm going to run in customers' runtimes, or like a little agent, or any kind of like CLI kind of thing that's going to live on like your laptop and talk back to my system, that part I'd probably write in Rust, because I really don't want to crash you. And then it's worth the overhead. Was that deserialization for the Sear Day crate? Yes, it was for Sear Day. Biggest complaint about malloc is the encapsulation thing. So many more than memory errors. Yeah. I don't know if I'd say that's the biggest. Oh, thanks, Milky. Yeah, so like, you know, let's finish this out quick. Performance, no garbage collection, manual memory management, lifetimes makes this safe for long-running processes. You may need to write an allocator. And this could be like a bump allocator. This could be like oh yeah, Zig's great. I'm using Zig build. The funny thing about Rust is like the build tools aren't nearly as good as Go. Go has a really good compiler chain. So you can kind of like, I'm on an M1 machine. I can compile for anything with Go. Like, you know, you just install Go and it just compiles anywhere. You can't do that with Rust. You have to like kind of beat it into submission. It wants to use the linker and that on my laptop, and that's a whole disaster. So you can use like an allocator, and these are kind of fun things to write. But these are my two biggest reasons. You get a lot of, with Go at a certain point, 30% of your time roughly will be in garbage collection at a certain size, you know, at a certain end point of your project. And sometimes you need that 30%. We use Zig build. It's wild. Like I literally don't run cargo build. I run Zig build to compile my application. Actually, we should probably leave that up. All right, let's get back to this. Did this go out? Okay, good. Okay, so I think that was 15 minutes. Let's find out. It doesn't replace either, man. Like, we got to stop with the whole, I don't want to blame you, Dota 2, that's what I'm saying, but like, it doesn't replace anything. It's just a certain tool. C developers who are really, really good at C, who have got really great projects in C, aren't going to just write them in Rust, because Rust is like safe, you know? So they're all going to live together, and that's fine. That's what they're for. There's nothing wrong with that. Yeah. Okay. So this is sweet. This is deployed. Love that chat on Rust, guys. That was a lot of fun. Did this go out? Remove. Okay. We removed that. When did this come out? This should tell me, right? 16 minutes ago. Okay. So this should be a pretty cold start. Not bad. Okay, so we want to, now we should have warm starts. Yeah, okay, now this is living for a while. Good. All right. Yeah, that is pretty good, Milky. I want to, I'm still seeing some conflicting results with the process uptime. That's an interesting figment of this that I have to figure out and have to experiment with. But I want to get this into the end-to-end tester. And to do that, we need a new Lambda function that can curl these endpoints. So both of these are endpoints now. You can hit this and run it if you want, you know. Boom, right, we can, and you see something similar, like the uptime is counting up in the same way. Do we have the same response from these? Oh, it's wrapped in resp. Okay, we should remove that. Pick your brain on Lambda architecture. Shoot your shot, Milky. What's your question? Happy to talk about Lambda architectures while we do this. Oh, duh, I wrapped it in an object. That's why it's there. I guess it might be a tough forum, like a one-way conversation, but more than anyone's welcome to ask me questions about Lambda or anything. Okay, let's let that build. And now we need a new project. Never stop me from peppering people with questions. Yeah. Why Lambda functions for integration tests? They're stateful, they're cheap, they're easy to throw away when you're done. That's a good reason. Say you have a RESTful or RPC backend, you want to go serverless. How would you architect that one, Lambda or multiple? And multiple, would you use to orchestrate them? I've done both. I'm leaning, so I wrote this whole, I did this a long time ago, and this blog post like gets a ton of traction. So this is like OG AJ shit. You can kind of do both. If you do the mono, yeah, I'll drop the link. There's some downsides with the mono. The biggest thing that I really try to do is I'll start with the mono API, and as soon as I want to write something, maybe so mono being like single like one giant Lambda function that runs multiple routes for my API. So it's one function, and in the API I do the routing, or I'm sorry, in the handler I do the routing. I'll like inspect the request, decide what it is, and route it to my code, but it's all one handler. I like that for a couple of reasons. One, I'm big on Docker containers for Lambda now, and it makes it really easy to put that right into Fargate if I want to. So if anything ever blows up, it's 10 lines of code or less. Like I demoed on live stream, AWS stream a while ago, how to write like a Lambda function container that can run simultaneously on Lambda or like App Runner or Fargate. Yeah, for sure. It's super, super easy. You can do this. It's there's two steps. You just have a container-based Lambda function, and then you use the Lambda runtime web adapter. And you would do that to save money, man. Like at some point you can always run your function in Lambda, and then if you have like a really big event coming, you can put it in Fargate, and then you can save a ton of money. And then just, it's the same exact code, same exact container image. You push the container image, it just runs wherever you want it, and then you can route it. Yes. So the Lambda function code is like, it's more written like a container. Let's see if I have this example. Oh, wow. What did we do? Where did I put this? Lambda performance, serverless Python requirements, param comparison. Did we do an AWS stream? We need to search for runtime or Lambda web adapter. This is going to show up. Let it chug. Let it chug. I have to find this. Yeah, not really. Why can't I find this? Is it in Twitch? Oh yeah, here, it's right here. Okay. So this is all this is. It's super, super simple. I use the Lambda Node.js base, but then I actually run a Node app. So it's still that you can do this from any, I'm just using Lambda base image. So it's got all the Lambda bits. And then I use this project called the Lambda web adapter. And this is also a Rust project. Rust, by the way. Is this a repo? We can make this a repo. And what I do is, here, let's look at the Lambda web adapter. This is a great project. Shout out to my friends at AWS Labs for this project. This lets you drop in, and once again, David, he's all over here. David's shipping code everywhere. This lets you drop in like an Express application or like a Go Net HTTP application into a Docker container and then run it on Lambda with no changes. So the Rust wrapper is an extension like we talked about earlier on the channel, and it will intercept the request for us, turn it into a HTTP request, and run it in our Lambda function, which is running like it's on a server. And the best part about this pattern is that then, I've just got this app, and this is just a regular app. We can just like, we can run, what is it, Node app? Can we just do that? Yeah. So we can just like go to localhost, right? Localhost 8080. Boom. I think this is back when Hack and Soul was in chat, and we like said hello to him. Oh, the reason why for this is because I can move it anywhere. I can move it anywhere. So Dota, that's what I'm answering from Elke. You can do both. You can create one Lambda function per route if you wanted to, per endpoint. That makes it harder to move. And it depends what you're building. So if I'm building an API, I tend to plan for those to outgrow Lambda at a certain point. Okay, so the first thing you have to learn is like, let's go back to Lambda. Dude, invite me. I'll go on your stream anytime. Let's go back to Lambda. Let's go back to the premise. How does Lambda work? Lambda is a Lambda function as a service. So each time you get a request, one request equals one invocation. Now, in an HTTP API standpoint, that literally means like for one user, right? You have user here. Let's just do a circle for user, and it's not Rust, so we'll make it plain. This is my user. The user makes the request, and I get one Lambda function. Like this is one sandbox. I'm not sure, Dota. I think so though. Okay, now this is for sync row requests. So this is where I try to take advantage of the asymmetry here, because for async requests, let's say you're reading off of a SQS queue, right? So instead of a user waiting for one request, I have this queue of messages. So we've got Lambda, we've got our SQS queue. Here, we can have many. So now we can have hundreds of messages, right? I can do like a batch of 500 messages here. This could be, 500 messages per request. Yeah, you're right, Nacho, but so it would be mono, but more importantly, what I'm saying is that Lambda today will only let me run one request at a time per sandbox. That is this like serverless function experience you get. The sandbox can be reused, but that's it. Yeah, so a queue though can take a batch of messages. So I'll use SQS and I'll use Lambda all the time for anything async because I can get this asymmetry. One Lambda function can run 500 requests. That's great. SQS means simple queue service. It's the very first AWS service ever launched. It is a ordered queue or unordered queue of messages. They're durable. So you write it to that queue and it can last for up to 2 weeks until you can process it. So if this function dies or has an error or restarts, you don't lose the message. That's the benefit. Very, very simple. Yeah, one of the best services. SQS, S3, those are like the big brain services. Lambda, big brain service. So I tend to use, when I'm building serverless, my APIs are tending more to land in Fargate or in App Runner. And then my asynchronous work is landing in SQS or actually a lot of it is in Kinesis and then runs in Lambda. And I think that's like the best bang for the buck. Because the downside of this, if you're doing a major, like if you're doing the same thing and you're doing this all in Fargate, you will end up in this situation where like you're polling, like this little Fargate box is just constantly listening for like long polling on a queue. And then you pay for that. And actually Lambda does this for you. The coolest thing is that there's a service that AWS runs that they don't tell you about. And you actually never directly connect Lambda to SQS. And there is no actual async invocation ever in Lambda. Everything ends in a synchronous invocation. So this is what actually happens. They do this for you. They pay for this for you. So when AWS pays for something for me, I like to use it. 28, welcome to chat. Thanks for chiming in. If you host a REST API in Lambda, you'll have max one concurrent request if you have one Lambda. Correct. Yeah, one request at a time, which isn't so bad. It sounds awful, but once it's flying, it's pretty fast. Like everyone in chat can hit this if they want, or they can hit the other one, right? Like where's here? Chat can just request this if you want. Try this out. And it's one request at a time, but it's very, very, very fast. In this case, there's nothing to it, but it will scale out additional sandboxes as it needs. And I think my concurrency limit's super low on this account. Need some magic red water there. I've been talking a lot. It can only handle one concurrently, one at a time. But it can handle, if the next request comes in, it can handle whatever that's for. So Milky, to answer your question, this is why I put a lot of stuff in containers for my APIs, because they tend to be something I move to Fargate later. Sweet. Okay, we got this. Now we just need to call these endpoints, don't we? Okay, let's get out of this Docker container. Okay. Okay, we need a few things. This is nothing. This should be node 20 because we don't want to use node 18. Yeah, you got it, Nacho. We want to be in US East 1 because these functions are both in US East 1. handler dot benchmark, and then we need two events, and this is going to run. Oh, not HTTP event. Good call, but no, we're going to run on a schedule. Right, let's not. We want at least 15 minutes. And it's plural. Okay, so that should be good for our infrastructure. And I don't think it needs permissions because we're just going to use fetch. Did you design your own website? No, no. My design is linked right at the bottom as per the agreement of their terms. So just found a free demo or a free thing. I actually took this photo. This photo was taken in India. Pretty sweet. Of a eucalyptus tree. Did that a long time ago, and then yeah, it's Jekyll. I've done Hugo. I've done a couple other stuff. AJ, the master of reading terms and conditions. You got it, man. Every time I open one of your repos and there's no like license.csv file, I cringe a little bit. I wanted to try Astro. I actually have something set up for Astro. I've just never gotten around to it. Okay. This should be called, what did we call it? Benchmark? Yeah, design is not my thing. I did a whole stream where I was working on a log structured merge tree in Rust and nobody joined. So I stopped working on like the things that are more like my actual work and just hack on this stuff on stream. I think less people are interested in the backend distributed system stuff like as a way to relax, which I get. I don't want to yuck anyone's yum, you know? Okay, we don't need to say this. We don't need to say this. We need to, how do we do this again? Reinvent 2023, projects, cold start benchmarker. Yeah, here we go. Bum, bum, bum. AWS embedded metrics, sweet. Okay. So we just need some metrics. Let me know if this is too small. Actually, we can... Oopsies. What is this? There we go. Still learning the tmux commands to resize everything. Yeah, data intensive. Yeah, the pig book, the boar book. It's great. Everything in any big data company with a lot of like Datadog is going to have some form of an LSM. LSMs are just like a general tree, right? Like it's a log, which means writes are fast, appending is fast. That's the idea. It's the fastest thing you can do. And then you have these ideas of levels and compaction. So there's a sorted string in memory where you are able to, it's for key value store. So you've got keys and values, and you keep that until this file gets to a certain size or a certain amount of time passes. Then you write that file. It's immutable. Once it's written, we write it to S3 or S3 binary store. We wrote a whole great blog post about this. Actually, y'all should read that. Like, there's 2 or 3 parts of this. Great. Richie Artool now founded Warstream. It's awesome. David, welcome to my chat. I was just plugging more of your work, David. David is the person that had helped work on this project. I think that's you, right? Yeah. And has also worked on Cargo Lambda, which if you're interested in Rust, definitely go check this out. All right, I'm going to plug the Datadog blog post. If you want to read about distributed log structure merge trees, read that. If you want to see some of David's work, go check out Cargo Lambda. Oh yeah, React. There you go. Bitcask and roaring bitmaps, and you can get into all of it. Typing Turtle, where do you work? I work at Datadog. That's why my name's on all these open source commits. Okay, what are we doing? Oh yeah, we're just curling this. npm I. Okay, AWS embedded metrics. Sweet, now we can embed a metric. I really hate these. This API is really annoying. Yeah, you have to create a metric logger. Then you have to log, okay. Let's just get that here, and then let's We don't have to return anything. We don't care about these function names. We can create an environment variable. URLs. Then cold start is true. That's fine. We don't care about this. What do we do? We did like a time, right? Yeah, we just looked at the time. Yeah, start, finished. Okay, so we can, this is great. Invoke Lambda function. We don't need this stuff. We don't have the ability to force a cold start on Vercel. That they told me about. Maybe they do have one. And we shouldn't say Lambda, even though it is, but it's just a function. Let's be cool. We don't care about this. So this is just a URL. Okay. Okay, so I'm copying the project I did for reInvent, and we're making it work with curl. We don't care about this. We don't care about this. So this is the result, and this should be await fetch URL. Start, finished, boom, boom. No more promises there. So we get a JSON response. What's our JSON request? Boom, boom. Handler runtime stack, good time, cold start result. So how long has it been since we made this request? Do you think, okay, if process uptime is like a couple of seconds, we know it's been live for a bit. Okay, that was a cold start. So that's a brand new one, and cold start true. So the reason I'm doing this is like, this will always be a cold start here. Oh, did we not do cold start true here? Dang it, we didn't. Let's add that really quick. Actually, we don't. Let's get this. Okay, so we'll modify our, I know I'm flying around right now, but I need to make sure this is working. Let cold, is cold start equal true? Yep. Okay. And we did the same, right? Process uptime, cold start result, handler init, handler runtime. Okay. One process has many threads. Dota, that is a loaded question. Can you clarify that at all? Can you give me more to go on? Oh, Node typically is a single process, single thread, but Node itself, starting in Node 20, has multiple threads. It'll run imports in a separate thread. It does a few other things. You can also use, I mean, there's a great book called Multi-Threading JavaScript Applications that you can buy. Shout out to my friends who wrote it. Building multi-threaded JavaScript. Where is the book? There we go. Brian English and Thomas Hunter. These are two of my friends. I work with them at Datadog. These are awesome. You should buy this book if you're curious about this. These are some really bright people. They work on Node Core. They work on Node Performance. They work at stuff at Datadog with me. They're great. Big fan of this. Yeah, so it's a single process, right? Okay, let's get this deployed. This should be right. I don't think it's that expensive. Also, you should expense it. If you work at a company that allows that, you should do that. And if they don't, you should ask them to. And if they ask why, they should come and talk to me, because developers buying books about software performance is a good thing for your company to invest in. And I'm happy to make that pitch. What other books do I have up there? Oh yeah, the database internals and designing data intensive applications is right up on the shelf behind me. All right, so this should be a cold start. There we go, cold start true, uptime 0.14. Okay, sweet. So now we have our URLs. Now we need to set this. Do you have specification by example? I do not, no. Functions, benchmark, environment. No Vercel, no Vercel project ID. No, I don't have that book. Copilot, every time it tries to help me out in Markdown, it just really cracks me up. Like, what is this going to suggest in this comment? You know, a foo bar, like. Okay, round trip time equals finish minus start. So I don't care about function name. Oh, should we do a map of URLs? That would probably be the right way to do this. We probably don't even need to do this in memory. All right, we don't have to do this as environment variables. We should just do this in a map. AWS, and then Vercel. Why is it not typing the L? You know, my linter doesn't have to freak out every time I don't use a variable right away. What did I miss? Oh, equals. See, everything's fine. We can even fold it. Now we don't have to look at it anymore. Okay, so we have our URLs. We have the key and the value. I kind of don't like this. We could do an array with a name. Or we could just destructure it. So handler TS is not called handler time type anymore. It's called handler runtime. Okay. Okay, so we just need this. And this should all work, right? Parse body. We get the body. We parse out the handler runtime. Then we just call. Did I really can't? Like, what a weird. God, I'm so weird. Why did I write run capital T time? Okay, that's fine. Request to handler time finished. Okay, so this is checking. We get 2 timestamps, right? We get the time it takes for our request to hit the handler and the time for the handler, like when it gets that request back to us. So we get a couple of points here. What we really care about is this round trip invoke. Invoke function. Why don't we just do? We can do like a map, right? Yeah, we could do like a URLs.map URL, and we don't want to put dimension. We want to do. Is this just the? This is the. What do we get when we map over an array again? Metrics used for performance stuff, logging for errors. Yeah, exactly. Like what I want to do is get just a bunch of metrics in CloudWatch out of this. We could do it in Datadog too, but there's enough names in this benchmark already. I don't really want to add my employer to it. I think this can be just between me and Vercel and AWS. So, why can't I remember how to map over? Is it object? And Twitter. Yeah, I mean, it's obviously going to be all over Twitter. Let's just do, yeah, here. Let me run a really quick test in Node because I forgot what this is. What do I get here? Oh, I can't map it. Oh, object.entries URLs. There we go. Okay. So we can do this. Object.entries URLs .map, and then you get 2 things. You get the name URL. These should be an array of promises. Invoke function. We don't need, yeah, we can just make this. Oh, wow, we didn't do that well. Chat, someone's supposed to check my typing. Okay, we pulled it together here. Someone who doesn't write JavaScript much anymore did it. await. Await has no. Oh. Will that await every promise? We'll find out. Cannot block declare. I'm not. Relax. What do you mean, comma expected? Did I delete something important? Probably did. That's fine. Okay. That looks good. What did I break? Oh, I've got a missing parenthesis, don't I? Oh! I accidentally hit a number instead of the right character. There we go. Jay, is there something special AWS does with the node environments compared to what's available in the AWS Lambda runtime interface client? There is the runtime interface emulator, which if you we want to talk more like, wait, what is this complaining about? Oh, this should be async, right? Like that. Yeah. Okay. Jay, do you want to talk about some real gossip right now? Runtime interface emulator. If you take this project, it's I think mostly Go, and you build it and you run it locally and you run it with Go debug enabled to show all, or like what is it? Go show loaded symbols. How do you do that? It'll tell you all the symbols. Go env var show symbols. Was it go trace something? Whatever. There's an environment variable to show you what symbols it loads. And it's the exact same as you get in Lambda. So they don't tell you, like, this doesn't seem to be this isn't the main repo for it, but they push it upstream and they kind of talk like there's some of this here. So this is more or less what runs in your Lambda sandbox, this project right here. And then the client is more or less what you get. It's just that each runtime has a little bit different client sometimes. So there's this thing called the rapid client. I believe that's now Rust. But if you look at like this gist, so I extracted Node 18's runtime. This is in the runtime directory. And this is the same for Vercel functions too. That's how I know. It's like, well, it's Node 20, but same thing. This interacts with that runtime interface emulator. And that's how they do like response streaming and all this other stuff. So it loads your code, and just like all good JavaScript, at the end of the day, what do we got? Await, do your thing. That's it. That's all there is to it. Okay, I think this is mostly done. I don't know how well this is going to work. We got a couple maps in here with asyncs that I forget. I think I got that right. I think my editor would have helped me with this. So we're waiting every 15 minutes. We're getting this. We're loading it, and we can trigger it. Let's just, you know what? What am I waiting for? Let's just get this. Let's just get this up to the cloud. Right? Nothing more to do here. Yep. Okay, let's just get this. Let's try it again. Let's just get this up to the cloud. Create that CloudFormation stack. It's been a super productive stream. Oh, yo, Marcelo, thanks for joining. Welcome to chat. Maybe put map inside of promise and all. Yeah, we could. That would run them all concurrently, which I don't necessarily need to do. We could. That would make it faster. We could put, we could do this, right? We could do... Oh, actually, yeah, you're right. Because is this going to return? This is going to return a bunch of promises. So this should be await promise dot. You're right. I'm sorry for saying that. I shouldn't have said that. I think you're right. I need this, don't I? The rapid client, is that just a fast HTTP client or something? It seems like it. I don't know. I'm not, you know, that part I can't, you know, say much about. There's a lot. I mean, I think the best answer I can really give here in is that it is the method of interacting with like Lambda's orchestration, which is like super locked down and isolated, but it's there. So there's this like client to like send the response back to like the main mothership, if that makes sense. I don't know if I'd call it a fast HTTP client. It uses HTTP clients. Yo, good call, Marcelo. I knew I was missing something. We'll get another deploy out of here post haste. Don't you worry. Oh, and you know what else we need anyway? We need, if this isn't a cold start, we should not do this because in Vercel we won't know. We can't set it. If res dot, oh yeah, we should. Okay, so we need to get the cold start. And I don't even know because like process.uptime should be longer. So like in Vercel here, that's a very short, you know, it says it's a cold start, but that's a very, very short process uptime. When we compare that against Lambda, you know, it's like 10x faster. So I wonder what they're doing. They both say it's a cold start. This is definitely slower, but I think if we ran like if we did a promise.all on like 70 of these and we had to like scale these up, we would have maybe not quite so great results, right? Like it's going to have, or like they said, if you wait 15 minutes and it scales down. So I'm not sure I'm super, I want to give this some time and see what it is when it, like how long this value is when it says true and it's actually slow to load. But that means we have to wait 15 minutes, but that's fine. This all has to deploy and I have to fix all this crap. So we need the promise.all. We need the, here, let's do a google.com 15-minute timer. Good. Okay. What are we doing? Oh yeah, we have to fix all my crap. So I need the response. What's the response? Cold start result true and process uptime. Okay. Yeah, David, thank you for that. The rapid client just takes events from Lambda's invoke API, returns responses. My understanding was there was more to it, but maybe I'm construing something and I just don't want to overstep. But yeah, I think yeah. So this is the response stream or like the response, you know, yeah, I think there's a little bit more than that. But for every invocation, it has an ID. Every invocation has a request ID. And then if you want to send the response like from your Lambda function, you're like, I'm done, I'm going to send this. You post it here to this route. And I think Vercel is probably doing some of this like custom. I know like Matthew Napoli is doing some of this for Bref. Yo, Owen Codes, welcome to the stream. Thanks for the follow. Join us in chat. Appreciate you stopping by. Yeah, so the rapid client like will handle this, I guess, in a way. But there is this like, so yeah, good point. In JavaScript, this is what they call the rapid client for the node runtime. This is the rapid client class. It has some constructor, has some body. No problem. We're working on. We're comparing Vercel and Lambda, AWS Lambda cold starts. Yeah, there's only 1 or 2 endpoints that use rapid client. Exactly. Actually, I need to pull this out of Lambda again and take another look and see what's changed. I used to do that a lot more. Okay, so we've got the cold start result and process.uptime. Now, what do we want to do? Should we return all this? Yeah, I think this method should be a pure function, right? Cold start result, process uptime. And then I think we should make the decision inside here and say if res dot cold start result and what should we say the uptime should be? I think it's got to be like, it's got to be less than or equal to like 0.09. Have we seen any less? Jay the developer, cheer with some bits. This is my first ever bits. Why use a VBS when you use containers just to use a Lambda function? Probably AJ Steinberg. Thanks. I mean, I put a lot of stuff outside of my VPS, but to be honest, they're a lot faster now. You know, in the time I've been building Lambda functions, they've really improved it. Y'all don't know how good you have it. Like Vercel as we know it would not be possible without all this work they put in. And I mean, mad props to the Vercel team too, because they've clearly done a really good job. It's really slick. But the Lambda stuff too, like, has gotten so much better than it used to be, including container images, including VPCs. Like the VPC stuff used to be horrible. You used to pay like a 10-second cold start penalty just to be in a VPC. And now that happens when you deploy your function, and it's so much better. Big improvement. Big shout out AWS. Yo, you got it next. So I need to, I really need to get some more commands. Do I not have GitHub? Nope. Oops. I have to remember how that worked. Sorry, I'm bad at Twitch, but I'm having a lot of fun. Okay, results.map, await flush, return true. That looks pretty good. I think we have to test it. Okay, so what would be our process uptime? This should be a cold function now. Oh no, still going. 293 seconds. Wowza. She's been up a while. Let's just kill this really quick. Let's find this function. What do we call this function? Just lambda cold start. Okay. Hey. Oh, hey, buddy. How's it going? Oh, you can open the door. It's fine. Dog's coming in to say hi, everybody. Everyone say hi to Taco. Hey, Taco. Everyone say hi. Oh, I'm sorry. The door closed.
It's fine. I'm standing out here.
Oh, buddy. You're welcome to lay on the carpet. He likes it here. Okay. Let's start. Of course he's gonna. Oh no, he's gonna lay down right behind me. 89 functions. Wow. Okay. Oh yeah, we still have bun here. We can do more bun stuff. Bun's cool. Configuration, environment variables, doggo. Yeah, that's Taco. Just editing this. We'll just get a cold start. So I can't do this in Vercel. They started themselves. So let's see. Now this should be, yeah, 0.09. So I think if we should expect it to be like less than 0.099, I think is probably fair. So less than or equal to 0.099. That seems fine. Put the metric. Else. Console.log. Probably not a cold start. Res. I was gonna add the curly braced. Taco is not yet. David, you're right. Taco's never impressed with the cold starts, which is fair. My wife isn't either. And you know what? They're both right. But I'm having fun. Okay, let's just deploy this. Then this is gonna run for like a week, and I'm gonna share the results. Once I make sure it's working, obviously, like, I'm gonna check that the code is functioning. But I'm so sorry, Vercel team. Okay, you got me already. I didn't do the thing. I forgot you had to do this. Sorry, everybody. Sorry. Okay, wait. Standard. Okay. Ooh, we gotta go back to this. Once again, I forgot to switch my view over. I'm not so good at this. I totally forgot how to do this. Well, we haven't taken any measurements yet, so there's no problem with that. But I want to standard memory. This is 1.7 gigabyte. We should do the same on my other function. I was using 1 gigabyte, but below 1.690 megabytes of Lambda memory, you get less than a vCPU, which means that you don't always get like the full. And that's done through Linux completely fair scheduler for process scheduling. So it means you just don't, like, at some point you might just end up halfway through your code sleeping, which we don't want for any performance benchmark. We certainly don't want that. And we should fix this here too. Tab edit, serverless.yaml, memory size. I think that's what it is, right? 1.7, yeah. Wait, let's just, I want to double check this. AWS Lambda memory size. I'm 97.9% sure it's 1769. Yeah, 1769. Okay, we memorized that one. Good work, chat. Okay. Deploy that. This is deployed. Okay, let's get a test in before. Bum, 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 bum. Oh, my music. Okay, we killed the music. Milky, do you know like a YouTube channel that has like DMCA free music? My wife took over my Spotify. I don't know if you're still here. That's fine. What was I going to do? Whatever. Let's just go back over here and find this. Vercel. Oopsies. I want to go over here and see if I can find... Yeah, lo-fi is fine. Oh, here we go. I think this is... Yeah, it's the same playlist. Okay, sweet. Harris Heller's... We're back. Just had to get off Spotify. Okay, what do we do? Bum, 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 bum. Let's just test this. Blop. Invoke. Reference error, cold start results not defined. What did I do wrong? What do you mean? Oh. Oh, we put it in the try. No. Who cares about this try block? Let's just assume it's going to work. It's okay. This can exit and fail. How's the music? Is that okay? Did I mix it right? Let's go a little bit lower. Dog's passed out. Okay. I had done that before because I had a ton of functions and I didn't have all of the right responses back. You should handle this. Oh, this isn't right anyway. Oopsies. Stop the music. It's not right. Res, you should just do, yeah. Well, let's just see what it is. Yeah, this is easy enough to do. Okay, so we parsed it twice, that's why. I think this is just parsed. Yes, I could test this all locally, but this is gonna be just as fast. Did it not log? Oh, it's object.response, okay. Okay. Song's shorter than I remember. Yo, I got my first 2 subscriptions lately, and I got my first bits from Jay. Thanks, Jay. That's super fun. What a banging weekend. And we got Vercel to give us permission to benchmark their system. That's the real W here. Okay. First try? What do you think, chat? Failed. Undefined is not valid JSON? What do you mean I didn't get a response back? Fine. Getting warm behind these lights. I really want to see how common this, like, probably not a cold start thing is. What are you mad about? Undefined, yeah, of course. Response. Oh, it has nothing? What? What? Which fetch? What a nerd. It's not a bash command. Oopsies. Dang it, I did it again. It should be dot then, right? Oh. Wow, there's a lot of HTTP debugs here, but I need the body. Why am I not getting a body back here? What's a readable stream? Oh my god. Node 20 fetch get body. Oh, .json, obviously. What's it like working with Datadog? I love it. I love it a lot. If you care about writing good software and you care about, you care about building high performance systems, I think you're gonna like it a lot. I've learned a lot there. I continue to learn a lot there. The people there are top notch. I have to await this too. It depends what you do. I think Datadog gets flack for pricing kind of everywhere, which is typical of any kind of incumbent in the same way AWS does. What is this? Response.json to then data. Res 2. Where is this bot? This is why people use Axios, man. So what is this? Fetch.then. Let's just, yeah, there's a reason people use Axios, and we can be that reason. I use the incorrect. Oh, Robin, hey, welcome to chat. Thanks. Yeah, I totally believe I used the incorrect line of code. I don't want to await 2 promises just to make 1 request. Boom, and it returns its .body. Yo, thanks for the follow, Elena CS. Much appreciated. That's just a post method. example. We don't want a post method. It's just response. Response.body or just response? Response. Let's try response. Yeah, so, okay. Let's just make sure we can do this, because I'm a total noob today, and that's okay. Can't win them all. There we go, resp.data. Okay, perfect. It's just right there. It's parsed. I don't have to JSON parse it. Let's try this. Oh, what finished here? Oh, this deploy finished. Okay, good. What did we change here? Oh, wrong thing. Okay, that's been running a long time. 600 seconds. Petite Code, hey, thanks for the follow. Welcome to the stream, welcome to the channel. Okay, yep, that's out. Let's go ahead and give that a click that test button. Diagnose with Amazon Q. We can try that. What doesn't it like? Can I represent undefined or equal to a result? What are my logs? Whoa, couple follows. Cloudby, Cloudby, welcome to the channel. Thanks for the follow. Line 34. Oh, we're all the way down here. So we made the result, or we made this. I wonder if my promise not all is not working and I'm getting this weird thing back. You know, what if I'm getting a, like I'm mapping over a promise here and then there's no, it's undefined. That seems likely, chat, which is fine. We'll figure it out. Let's log some results. The old guess and check method. What we should be using is a library I wrote for serverless framework to do these really fast deployments right now because I'm not changing any of the infrastructure. But as usual, I thought this would go really fast. That's how it goes. You win some, you lose some, and a lot of the times I lose these. All right, the dog is passed out right now. Y'all gotta see that. He's just snoozing. Just snoozing by the plant. Okay. I know it's gonna be an error. I don't care. Oh wait, this isn't the right one. We didn't. There we go. Here we go. Oh yeah, undefined, undefined. Great. Wow, lots of these undefines. Why am I not getting a result here? Oh, I don't return anything. Of course. Yeah. Well, we can check to see if our function ran, right? Because this will be warm. Yeah, so that's been, okay. So it's working. It's invoked. We're making, Axios is working, saving us again. I didn't want to chain two awaits together for my node fetch. One day we'll figure out the API for nodes fetch. Not today. Oh, this timer went off a long time ago. Why didn't it beep? I don't know why I didn't hear it. Chat, did you hear it? Guessing not. Anyway, thanks so much, Robin, for joining the chat, and everyone else who's here. I appreciate it. Drop a follow if you like talking about and learning about AWS stuff, Lambda, serverless, or eventually I will try and get a stream together for that log structured merge stream project again, the distributed LSM tree. There was very little interest in that last time I was working on it, but I think it's just not as interesting on stream. A lot of people like to see the Vercel stuff, so we're working on it. I'll get that deployment out. Oh, that succeeded. What do we got here? Nope, that's not right. Oh, dog left. Hey, here we go. Probably not a cold start from AWS. Probably not a cold start. We did it. Okay. Why is this? Oh, it should embed no, but there's no metrics to send. Yeah, I said none. So, okay. All right, chat. So here's what we did. We got this working. Hell yeah, this works. Okay. So this is just going to sit and run. It's going to run every 15 minutes. It's going to run every 15 minutes in perpetuity until I kill it, which I will do it at some point. And it is running both our Vercel. Oh, we should create a, we should make this open source. Although I don't necessarily want to keep, I don't want all these URLs to be open source. I should create a new project because this is all out there and I want it to like sit there and bake. It's fine actually. It's just a project between you, me, and the 12 of us here. 13. Speaking of which, thanks for dropping by. If you're new here, I'm AJ. I work on serverless stuff at Datadog and write a lot of, I mean, today I wrote a lot of JavaScript for the first time in a while, but otherwise I've been writing a lot of Rust. We probably don't need these results or this. This all works now. I could clean this up and release this. I think that's totally fine. We can make this a environment variable and then just suppress it and redeploy this project with a new private name. Then we don't have to worry about it. And I can even encrypt this. And if y'all are new to Lambda, I wrote a whole blog post about secrets in Lambda called The Ultimate Guide to Secrets in Lambda. So if you don't want your secrets to leak, like this secret right here, I had to write CSS for this chat. Come on. You can read this blog post. And what I can do is I can probably encrypt these endpoints, which just so I don't leak them in chat. Or we could even, I could salt them in base64 it. That would work too. But yeah, check it out if you're looking to keep your secrets safe. Awesome. This is running. That deploy's finished. It parsed both of these responses. That's good. This is public. Oh, I should make, okay, so this needs to be public too. Should we rename this directory? Probably. Actually, yeah, let's... No. I can put this all in the same directory, or we can just create this open. I'm not sure. There's nothing to this. I guess we can always look at the VOD if there are questions, but there's literally... It couldn't be a simpler Lambda function. We can publish this, though. Cool. And this is rolling. This is great. So we let this sit long enough. These functions should both spin down. Cold start result will be true, and then we can actually get that end-to-end latency. We're measuring it from a different. We are measuring it from a different Lambda function in US East 1, and we're doing that to cut down on network time. Oh yeah, we talked about a lot of stuff on this stream. Okay, so quick recap if you're new to AWS or Lambda. AWS is composed of 33 regions. In each region is 3 or more availability zones. 3 is a magic number for distributed systems because you need a quorum. You need an odd number to vote on who will be the leader. So distributed replicated data systems like Kafka or DynamoDB or Cassandra all have this concept of a quorum. Well, Cassandra through Apache Zookeeper, but you get what I'm saying. There's this, you need to break a tie. So you need an odd number, and there tends to then do that geographically. And in AWS, these are actually separate buildings on separate floodplains. It's pretty cool. They're like physically segregated. They have like 100 gigabit fiber between them on their own like backhaul lines. But the whole idea, and this should be a double-headed arrow, the whole idea is that you get this huge geographic resiliency, right? Redundancy within it. But the downside for us is Lambda can run in any of these buildings. Any function you execute can run in any of these at a time, and we don't control it. So we want to just take a bunch of end-to-end measurements over time and then see if we can like establish a trend and kind of filter out some of the noise. That's what we do. This should work, right? Should be 15 minutes. Oh, perfect. Okay, sweet. Let's quick look at the metric. Okay, we tested it. So everything's warm right now. These should fire down soon. And then we should get a result. And I want to try and get 1 point before we go. But I really appreciate everybody hanging out. This has been super fun. Got up to, I have 240 followers. That's crazy. Thank you so much, everyone, for following. I had 180 followers going into this weekend and decided to do a stream for Vercel. And then I saw that terms and condition that they wouldn't allow anyone to benchmark it. And shout out to Vercel for giving me permission really quickly. So now we're in this process step where we're gonna run this benchmark and let this sit for a while, for a good long while. This code, yes, public. Okay, so I should open source the other stuff too. We should just do like a curl-based wrapper, and yeah, I guess we can refactor this to be outside of these URLs or in here. We could do, what's the easiest way to do this? It's an environment variable. We could do key value pairs. We could do like AWS or Vercel, or we could split and map. But then the order really matters, which I don't know if I want to do. I can do this. Oh, we shouldn't name it that. That's a reserved name. Cold start Lambda and cold start Vercel. Okay, that's better. Sweet. Okay. Now I can at least push this up because I'm going to delete all these and rename them so I don't run up a bill. Not that I'm that worried about it, because I have low concurrency limits and budget alerts and everything like that, which are good things to do. You should set up a billing alert. First thing you do when you start a new project is set up a billing alert. Cool. Okay. Oh yeah, this should be okay. So we'll do env cold start Lambda. So read this out of the env. Cold start. Okay, just a little infrastructure here, folks. Nothing to worry about. That should work. Okay, then we need to tear this down, redeploy it, hidden. I don't know how to do that for Vercel. This is easy enough to do, though. Fine, so let's remove. Oh, this function's about to fire, though. I guess I don't want it to crash. 10 minutes ago, it's fine. I think I can race it. Yeah, we can race it. I have to figure out the Vercel part first. That might be a little trickier. Can I rename this thing? Project name? Oh, I can. I can just give it a rename. Okay, so I'll do that off stream, or we can. Here, 1 second. Yeah, I don't want to leak it, but I want to see if this works. We have 4 minutes left. We can do that. Oh, actually, did this fire already? It did. Hey, Dax. Obsessed with the serverless framework. Man, I just have it memorized. You missed at the beginning where I got in a fight with TypeScript, and I was just mad. And it's like, you know, with JavaScript, this would be done. And then, you know what happened? I had a bunch of runtime errors because I didn't know any of my types. Rust solves this, Dax. That's what's most important. Okay, I think we can do this, but let's at least get this in a repo so we can do that. Vercel plain function, so that's on a repo. All open source. I promised everybody this will be all open source, and I'm sticking to it. Welcome to the channel, the Dax. What do we call this? Oh yeah, owner, just me. Okay. Let's just get init, right? And then, yeah. We don't have any node modules. Oh, good. Okay, it's already done. No secrets in here? No. Cool. Okay. I hate that commit-am. I did that every single time on stream. Not once did I get that right today. Doesn't add a file. You have to get at it first. All right. We all open source there. That's great. 2 minutes left on that Vercel. Okay. We got that, and then we can do the open source for the benchmarker itself. This doesn't have anything in it, does it? No. Um, 50 repositories. Man, it's getting wild. Vercel, AWS, function comparison. Work in progress, people. Wow, I had the one opportunity to get that right and I blew it. Whatever. Whatever. NeoVim Tmux, by the way. All right. This work? Good. You know what? At least I left nothing left out there, right? I got tried everything, did it all publicly. We'll get to see what the results are as we let this sit. When did this run last? Oh, 20. Okay, so it ran 8 minutes ago, I think. Oh, yeah, at 20, okay. Both of them not a cold start. That's fine. Okay. I wonder, does EventBridge tell me when the next event will be? I guess it was 8 minutes ago, so we can just do the math and say it'll be at 35. That is fine. As long as we don't hit this, we're fine. As long as none of you in chat hit this, you're fine. We're fine. But it's okay. We skip it anyway. So, okay. What I have to do, I have to hop off stream. I have to rename this to something that people won't hit. I have to delete this and recreate it, which are both easy to do. Then deploy it, and I'll let this run overnight and see what the values are. So I think we're going to go do that. Once again, thank you all for hanging out. A bunch of people in here. Oh, there's our timer. Finally, we make some noise. Thanks for hanging out. Appreciate it. We're going to go raid Mr. Chris Griffin and hang out there. But I will let everyone know what happens next. Of course, you can follow me on Twitter. And please, if you like the channel, follow. Really appreciate the support. Thanks, everyone. Have a great night.